everyone, it's Mick. Welcome to my shop. So this week I'm working on a Morse Taper 2 quick change tool holder for my lathe. So the idea is that this will allow me to use Morse Taper 2 tools directly off the quick change tool post on my lathe. So for example, drill or even a center or something like that. If I'm doing some sanding or finishing on a part, I could just use the live center there. But use your imagination. It allows a lot more flexibility, I think. I was originally thinking about buying or making one of those tool post drill chuck adapters, and the more I thought about it, this seemed like a lot more flexible solution. So anyway, as you saw, I just cut the stock to length, and it's going to be an interesting process, I think, because well, I'm going to learn a lot. You may not find it interesting. A lot of you don't find my videos interesting. But in this particular project, I'm going to be doing a lot of things that I haven't done before. So a lot of learning. I'm going to be using the lathe sine bar from Tangent Engineering to lay out the angle on the compound, actually using it for the first time on a real project. I'm going to be using my Dumore tool post grinder to clean up the inside of the Morse taper hole or whatever that I'm making. I'm going to be using the dovetail cutters that I bought from Randy Richard in the shop, geez, probably 3 years ago now. So yeah, a lot of to me interesting things. If you find it interesting, do me a favor, give me a like and subscribe. Anyway, let's get started. Alrighty, I've got the blank roughly sawn to size from the bandsaw, and now I'm just going to do the standard typical square it up. So I figured I would spare you the painful details of me squaring this piece of stock up. I can't tell you how many cutters I went through. I dulled several end mills, inserts were ruined. As you'll see when we get here later on, it was very, very tough material. And I finally came to the conclusion that it worked hard. I'm guessing it's some sort of tool steel. Would not have guessed that because it was a rather large block, but it's very heavy, and when it's shiny, looks like tool steel. So yeah, I think it's some sort of tool steel. But yeah, you'll see there as we go on. Let's check the, wow. I don't know what this steel is, but it seems tough. Maybe after I get it pretty close to done here, I'll do a hardness test on it, but I think it's worn out those inserts, because that looks terrible. Alright, I've got 4 of the 6 sides square and 2-dimension. So next is squaring up and getting these ends cut 2-dimension. And I'm going to do that by using an end mill on the end. Okay, I just checked my dovetail cutters to make sure they are correct for the dovetail that I need to mill for this, and they are. These are the Randy Richard in the Shop Special Edition dovetail cutters, and this will be the first time I've ever used them. And I'm glad they're carbide, because this stuff is hard. I am going to, goes this way. Yep. I'm going to take it out now, and check the hardness on it. It dulled 2 high-speed steel end mills in no time flat, and then dulled the carbide inserts I was using on the last cutter. So can I get the hardness checker tester, and I'll be right back. Alright, let's get the hardness tester out. Get this set up. There we go. Alright, I've got it set for Rockwell C HRC scale, steel and cast. So let's see what this thing is. I'm going to do it on this side because I'm going to be milling out here for the dovetail, so if there's any indentations they won't show up here. Alright, all is set. 41.7. 42.6. 41.7 for an average of 42. So yeah, that's kind of hard. Alright, so from what I've been able to determine, mild steel has a hardness on the HB scale of 120. So let me see what that converts to. 120 doesn't even show up on the Rockwell C chart. So the Rockwell, this was 42, which is 388. don't know if you can see that. 42 HRC, which is 388 on the HB scale. So yeah, I'd say this is some hard stuff. In fact, the calibration block that came with my hardness tester gets significantly bigger dents in it than this did from checking the hardness. You can kind of see them there, but it's harder than the test block. So yeah, well, I guess good and bad to everything, as usual. The good is it won't wear out as fast, being put in and out of the tool post and used, but yeah, it's going to be a bear to make. But we're almost there. So, next step is to put a carbide end mill in here and mill down the sides to size. I think my 1/2 inch carbide end mill, yeah, that'll work. And I think I'm going to put that in an actual end mill holder. Assuming I have it on this 1/2 inch. Well, as you can see, I did not use an end mill holder. I just used an RA collet because my end mill does not have a flat on it for an end mill holder. Okie dokie. Very nice. Alright, I'm going to flip that around, and then I might actually even try using some anchor lube or something on it to help. Well, it's hard, but man, it leaves a beautiful finish. And for this one, we're going to 3.5. We're at 3.617. We got to go down 0.117. Honestly, I'm thinking about just leave it. Who cares if it sticks out just a little bit more? You know what I think I'm going to? Rather than take a chance on ruining another end mill. Alright, I'm going to go deburr this and then plan my next operation. It occurred to me as I was laying out the rest of the operations on this, that I do need one drilled and tapped hole. And this stuff is so hard, I don't know if I can do that. So I'm going to try it on a piece of scrap left over here, and let's see if I can even drill and tap it. If I can't, then I guess I start over with another block of steel, something a little softer. Let's see how the drilling goes. At least I can sharpen a drill bit. It's not going too bad. Of course, these are some really good drill bits from Drill Hog. Alright, that gives me some hope. Well, let's see what happens when I try to tap it. I'm just going to try it by hand here on the mill. Oh, and I used a oversized drill bit. Looking at 3/16, or excuse me, 3/8/24 for the screw size. Seems a little backwards to me, but from what I understand, and Mr. Randy Richard is one of the guys who taught me this first, is that fine threads are actually easier to tap than coarse threads. So grab a tap and I'll be right back. Alright, I'm going to start off with a Vermont 3/8/24. Doesn't say where it's made, but I'm going to start with it because it's got an easier tip to start with. And I'm not going to worry about being too, oops, guess I'm not going to worry about much, just throwing the tap around. Oh, man. Okay. I can even see chips Well, maybe this won't be too bad. Or is it that maybe this is work hardening on me when I'm using these high-speed steel tools? I should try checking the hardness on a piece of this that has not had that done. Because this is tapping easy. I am going to try drilling another hole with a drill bit that's closer to the right side. And by the way, guys, this is pretty much a first for me. And what I mean by that is trying something out and experimenting on scrap metal, and see, I learned my lessons. I'm not just diving right in and doing, you know, these operations on the final part. So I think that deserves a hit on the like and subscribe button. Just saying. And maybe even a comment. Comment would be awesome. And while you're commenting, maybe you can tell me what your guess is on what this material is. I can hear the chips getting a little crunchy in this one. But it's still tapping pretty easily. I guess I just went all the way through. Alright, that wasn't so bad. Let's try the one that's whatever size it's supposed to be, which I think is S, or I don't remember. I've got to look it up. Alright, that worked, and there's a bit more thread there I can see. So let's try the next one, which is actually what's recommended for softer metals. So this one I may have trouble with. Yes.
From family room.
Dinner is ready.
Well, sounds like it's dinner time, folks. I'm glad I did that. That makes me feel a lot better. About doing it on that part. Alright, I've got the 4-jaw chuck installed on the lathe. I've got the part in it, and I just finished indicating it in so that it is square. I need the 4-jaw chuck because the hole that I'm going to drill through this end is off center. Start off with a spotting drill. I did some research on this metal that I'm using here, and it's likely that it's a form of tool steel. From what I've read, tool steels can work harden, and the normal range for that is right around where I measured on this. I think maybe later I'll try taking a hardness test on the blank that the piece that I drilled and tapped for a test, and see if that is any softer. I am going to drill this out, maybe 1 or 2 drills, because one of the things that I read is that in order to avoid work hardening, go slower and take bigger cuts. Ow. Alright, let that cool off. I need to go find out what size drill bit I need for the small end of a Morse taper 2, and then we'll come back and drill that out. Alright, according to the Engineer's Black Book, the small end of a Morse taper 2 is 0.588. The closest drill bit I have to that without going over is 37/64. So we will drill that all the way through, and then it's time for the boring bar, and got to set the compound and do all the angly stuff. I know you're not supposed to do this, but I don't have a drill bit long enough to go all the way through, so we're doing what we have to do. Alright, we're through. Yeah, that was not bad at all, but you could definitely tell that those outside surfaces were hard. Drill bit's smoking again. And one of the best decisions I made was to invest in a good set of drill bits. These are not those. These are some cheapo drill bits from Amazon, but they seem to hold up pretty well. But the other ones, the Drill Hogs, if you need drill bits, not sponsored, I buy everything that I buy from, or I buy everything that I have from them. But you can't go wrong with Drill Hog. They're made in the US. They're lifetime warranty. Save your receipt, save the little barcode sticker that comes with them, because if you need to get a new one, you'll need that. But they are fantastic. Alright, so I've taken the solid tool post off of the lathe, and I've put my compound slide back on, and then I've got my sine bar plate that I made. I made a video about this, mounted to my my compound. This is only needed if you have an older lathe like mine that has the kind of compound that doesn't have any straight sides on it. And then I've got my lathe sine bar from Jim Enos from Tangent Engineering on here, and then I indicated in the sine bar with the appropriate set of gauge stack blocks over here on this end. And I believe I've got it set now at the proper angle to cut a Morse taper 2. But I took the 4-jaw chuck out off of the spindle because I didn't want to have to re-indicate in my part. I'll check it again, but it shouldn't need to be messed around after I put the 4-jaw chuck back on. And I'm just going to cut a test piece to make sure that I'm really cutting a Morse taper 2. So that's about all, I think. Yeah, let's cut some test pieces here, or a test piece. I've got the 4-jaw chuck back on the lathe, and I ran an indicator and double checked that nothing moved, so that looks good. I've got the compound is still set up. I got the boring bar in it, and should be set to start boring. So let's see how it goes. Alright, I'm pretty sure that that's not nearly far enough, but I just want to check it and see if we're even starting to get a Morse taper 2 able to insert into the hole yet. So I'm leaving the compound and the cross slide right where they are. I've got my DRO zeroed for the carriage, so back that off. And let's see, I'm going to get some air here. Yeah, definitely not the smoothest finished in the world. Alright, we're making some progress. Keep going. I want to leave enough room that I can ream it to the final dimension. That'll take care of any problems I have with my setup here, hopefully. I think I either need to make some blocks, possibly buy the ones from Jim Enos that are made for the sine bar, because I cannot get a stack of gauge blocks beyond 3 decimal places to set the angles. Maybe that's enough. I don't know. We'll see. Alright, I think I'm going to ream the rest. Hopefully I'm close enough that I won't be reaming forever. Nice. Okay, so get this out of the way. This is a roughing reamer. You can see the teeth on it, and then here's the finish reamer. So I am going to use the tailstock with a center on it to provide pressure. I'm going to lock that, and I'm going to take the tool post off, give myself some more room. Alright, I'm set up for reaming. I've got the roughing reamer in there with some anchor lube on it. I've got the tailstock set, and let's go for it. Alright, let's see how this thing is looking. Don't really see any chips there. I would have thought I would be seeing some chips there. It's definitely smoothing out some areas in there. think I might have got it a little work hardened again. Oh. Oh, but I do seem to be cutting chips now, or at least making a mess. Yeah, no more rocking. I have a feeling if I were to tap that in, I wouldn't be able to get it out. Let's keep going. And then I want to do a finishing pass. All right, attempt number 3, or shall we call it Plan C, for getting this Morse taper 2 done. Now, let me get something to cover those ways. This little project to make this tool has allowed me to use quite a few things that I have never used before, including using the lathe sine bar for a real actual project, not just to show how it works or anything, and then to use the Morse taper 2 reamers, which look great, but they didn't work out on this case because I think this steel is too hard. And now a chance to use my tool post grinder that, and I've never used a tool post grinder before at all. So I've got the compound adjusted to the, I hope, correct angle. Let's give it a shot. Worst can happen is I scrap the part. Alright, let's get this spinning a little bit. Keep this away from the spinning jaws. Start right there and come in just till it's contacting. Okay, I'm back. I just wanted to verify that I had enough stick out here from the end of the spindle to cover the full width, the length of the Morse taper, and I do. It's more than long enough. And I have enough travel on the compound to go in to cover more than that distance. So I'm just going to, I know that I'm going to be going past on that end down there, the small end, that I'm going to be going past that distance there. So something like that. So that should be good enough. So I'm going to figure out where it's rubbing around in here, and I'm just going to start making passes and hopefully I'll be able to hear when it gets to the point inside where it's hitting down to the bottom. Get some more die-chem on here. Get my safety glasses on, and let's see if we can get this thing wrapped up. I don't know if you can hear that over the lathe, but it is grinding inside there. And then it drops, and now it's grinding again, so it seems to be working. I gotta say, I'm very happy with the way this little grinder is working now. I moved the switch to pulleys, and it's working quite a bit better on the other set of pulleys. It was bogging down before. I think I slowed it down, gave it some more torque. It's still spinning pretty darn fast. I've got absolutely no rock. Try it with a different Morse taper. Yeah, I can't go any more than that. This is almost bottomed out. So. Alright, well, we're just going to go with that. If this works, great. If not, won't be the first time I made something that didn't perform as I had hoped. So we're going to call this part of the operation done. And the next thing to do is to mill out the dovetail section on this face, and then it'll go flipped around, so there will be a then I need to drill and tap for the height adjustment somewhere in here. That'll be the last thing I'll do, and God forbid tapping into this. I hope I don't break the tap on the last operation, but the material tapped just fine before I work hardened it, and hopefully the hardened part is relatively shallow, I hope. Alright, so I'm going to get this cleaned up. I'm going to put the grinder away, clean up all the grinding dust, put the lathe back to normal mode, no compound for the taper, put the 3-jaw back in, and yeah. So that'll be the dovetail. We'll do that in the next video. This is probably getting to be too long as it is. So thanks for watching, and do me a favor and hit the subscribe and the like. I've noticed that a lot of the viewers I get are not subscribed, so please do me a favor and subscribe. I really need the help on that. Thanks a lot, and take care, and we'll see you next time.